Hello class, let's look at the mole percent composition and elemental analysis. How many moles of sodium chloride are in a 7 gram of sample? First, let's find out the molar mass of sodium chloride. Molar mass is the mass of the sample in grams of 1 mole. So you can do this easily by adding up the masses of sodium and chlorine. So sodium is 22.99 and chlorine is 35.45. That makes 1 mole of sodium chloride is 58.44 grams. If you remember the dimensional analysis, we can write down this information as fractions in two ways. That means 58.44 over 1 mole or 1 mole over 58.44 grams. So let's do a dimensional analysis here. So we take the 7 gram of sample, which is the subject of our question, and then we are going to write down one of these fractions in such a way it cancels out grams to grams. So I am going to choose this fraction, 58.44 grams in the denominator, and you can see grams to grams cancels out and you are going to end up with the number of moles. So the answer to this question is 0.120 moles. How many moles of oxygen are in 12 grams of carbon dioxide? When you look at the carbon dioxide molecule, you see that it has one carbon atom and two oxygen atoms. And the same ratio goes with the number of moles. 1 mole of carbon dioxide consists of 1 mole of carbon and 2 moles of oxygen. So we are going to find out the molar mass of carbon dioxide and you will get 44.01 grams per mole. Now we are going to do dimensional analysis and we are going to start with the 12 grams of carbon dioxide. So you are going to write down 12.01 grams carbon dioxide and then we are going to use this information. So you are going to write the fraction here, 44.01 gram carbon dioxide in denominator so that you can cancel this one and this one out. And the next step is to get the number of moles in the equation. Now you have answer in moles carbon dioxide. So 1 mole of carbon dioxide has 2 moles of oxygen. So we are going to use that fraction here and you can see more carbon dioxide cancels out to more carbon dioxide and you are going to end up with more oxygen. So the answer to this question is 0.545 moles. Calculate the number of helium atoms in 9.50 gram sample. So remember helium is monatomic and the mass of the helium is 4.003 grams per mole. And we can write this information in two fractions and you are going to need one of these fractions in your calculation. Also remember 1 mole equals to this many of atoms. We call this Avogadro number and you are going to use this information as well. Whenever you are asked to calculate the number of atoms, remember you always have to use the Avogadro number. So let's do the dimensional analysis. We are going to start with 9.50 gram sample, which is the subject of our question. And we are going to use one of these fractions. So you figure out that this fraction is the one going to be in here so that we can cancel out gram helium to gram helium. And in this part, the answer is going to be in moles. Now we have to incorporate the number of atoms. For that, we are going to use this information, and we are going to write the fraction as 1 mole in denominator so that you can cancel out 1 mole to 1 mole and then end up in the answer helium atoms. So the answer to this question is 1.43 times 10 to the 24 helium atoms. Calculate the mass in grams of part A, 8.22 times 10 to the 24 aluminum atoms. Part B, 3.44 times 10 to the 25 Br2 molecules. Let's do part A first. So we are going to find out the molar mass of aluminum, which is 26.98 grams per mole. And then these are the information you are going to use in your dimensional analysis. You know from this 1 mole of aluminum weighs 26.98 grams. And whenever your question mentions atoms, you have to use the Avogadro number. We know 1 mole of aluminum equals to 6.022 times 10 to the 23 aluminum atoms. Let's do the dimensional analysis, and we start with 8.22 times 10 to the 24 aluminum atoms, and we are going to use this information as a fraction in such a way that the aluminum atoms to aluminum atoms cancel out. And then in the next step we are going to incorporate the mass. So we use this information as a fraction, so you can see mole aluminum cancels out to mole aluminum. So the answer to the part A is 368 grams. So part B, we do the similar thing, and we are going to find out the molar mass of Br2 molecule. You know Br2 is a diatomic molecule, so we have to multiply 79.90 by 2. That makes your molar mass to this. So these are the two information you are going to use in your dimensional analysis. From this you can see 1 mole of Br2 weighs 159 grams and 1 mole of Br2 has 6.023 times 10 to the 23 molecules. So we are going to start with this many of bromine molecules, 3.44 times 10 to the 25 bromine molecules, and then we are going to use this information. 6.022 times 10 to the 23 Br2 molecules over 1, and this cancels out to this. And then next step we are going to incorporate the mass from this information. So you are going to put your moles in the denominator so that it can cancel out to this. So your answer to part B is this. Find the percentage of carbon, hydrogen and oxygen in glucose. So we have given a molecule and asked to find the percentages of these elements. So when you look at the glucose molecule, you notice that it has 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So you can find the molar mass of glucose, which is 180.16 grams per mole. And then these are the other information you need, the atomic masses of carbon, hydrogen and oxygen. So the mass percentage of an element equals to mass of the element over mass of the compound times 100. So let's go to carbon. The mass of the compound is 180.16 grams per mole, and we know that we have 6 carbon atoms and 1 carbon atom weighs 12.01 grams per mole. So your mass percentage of carbon is 40. Then let's go to hydrogen. The mass of your compound is 180.16 grams per mole, and we know we have 12 hydrogen atoms and one atom weighs 1.008 grams per mole. And this is your mass percentage of hydrogen. Let's do the same thing to oxygen. Your compound mass is 180.16 grams per mole, and you have 6 oxygen atoms and one atom weighs 16.00 grams per mole. And this is your mass percentage of oxygen. Find the masses of each element in 38 grams of glucose. From the previous question, we know glucose has 40% of carbon, 6.714% of hydrogen, and 53.29% of oxygen. So when we consider 100 grams of glucose, it has 40 grams of carbon, 6.714 grams of hydrogen, and 53.29 grams of oxygen. We are going to use this information in our calculation. So we are going to start with 38.0 grams of glucose, and 100 gram glucose has 40 grams of carbon, and you see here this grams glucose cancels out to grams glucose, and here's your answer, and it has 15.2 grams of carbon. Same thing goes to the hydrogen. 38.0 gram glucose times 100 gram glucose has 6.714 grams of hydrogen. This cancels out to this, and then the answer is 2.55 grams of hydrogen. 38.0 grams glucose times 100 grams of glucose has 53.29 grams of glucose. The answer is 20.25 grams of oxygen. Determine the empirical formula of a compound that's 62% of carbon, 10.4% of hydrogen, and 27.5% of oxygen. So when we have given the percentages, immediately we consider 100 grams of the compound. When you take the 100 grams of that compound, it has 62 grams of carbon, 10.4 grams of hydrogen, and 27.5 grams of oxygen. So we know the masses, and then we're going to convert these masses to moles. To convert the masses to moles, you need the molar masses of these elements. So you go to the periodic table and find the molar mass of carbon, which is 12.01, and molar mass of hydrogen and molar mass of oxygen. So we are going to start with 62 grams of carbon because 100 gram of the compound has 62 grams of carbon. This is the amount we are going to convert to moles. We are going to start with 62 grams of carbon, and we are going to use this information in a fraction so that it can cancel out grams carbon to grams carbon, and the number of moles of carbon are 5.2. We do the same to hydrogen, and the mass of hydrogen is 10.4, and we are going to start with that, and then we are going to use this information in a fraction in such a way that it cancels out gram hydrogen to gram hydrogen, and the number of moles of hydrogen in this compound are 10.3. We do the same thing to oxygen. The mass of oxygen is 27.5 grams, and then we are going to use this information in a fraction, and you see this cancels out to this, and then the number of moles of oxygen are 1.72. Now we are going to develop the empirical formula. We are going to write down the ratios C2H2O, and we have 5.2 moles of carbon, 10.3 moles of hydrogen, and 1.72 moles of oxygen. And then we are going to divide all three numbers by the smallest number. Smallest number of these three numbers is 1.72. When you divide, you will see the carbon carbon to hydrogen to oxygen ratio is 3 to 6 to 1. So your empirical formula is C3H6O. Determine the empirical formula of a compound that's 82.66% carbon and 17.34% hydrogen. That means immediately we are going to consider 100 grams of the compound. So this information means 100 grams of the compound has 82.66 grams of carbon and 17.34 grams of hydrogen. And we are going to convert these masses to moles. For that, you are going to use this information, which are the molar mass of carbon and hydrogen. So we are going to start with the carbon. It has a mass of 82.66 grams, and then we are going to use this information in a fraction so that we can cancel out gram to gram, and we are end up with number of moles. So this 82.66 grams has 6.883 moles of carbon. We are going to do the same to hydrogen. The mass of hydrogen is 17.34. We are going to start there and then use this information in a fraction in such a way that we can cancel out gram hydrogen to gram hydrogen. And we are going to end up with 17.20 moles of hydrogen. Now we are going to write down the ratios. Carbon to hydrogen, we have 6.883 and 17.20. And we are going to divide these numbers by the smallest number, which is 6.883. This makes 1, and you will see this one is 2.5. When you have a ratio which is closer to a real number, we are going to write it down as 1.2.5, and then we are going to multiply this whole number by 2. Then we can get full integers. This will make your empirical formula to C2H5. A compound with the empirical formula of CH3O2 has a molar mass of 235 grams per mole. What is the molecular formula? So you need to remember that the empirical formula is the simplest form of your molecular formula. First thing we are going to do is to find out the molar mass of the empirical formula. It has 1 carbon, 3 hydrogens and 2 oxygens. So the mass of the empirical formula is 47.034 grams per mole. Now how we going to figure out what is the ratio between actual molar mass and molar mass of the empirical formula. So we are given the actual molar mass as 235 grams per mole, and we found out that the mass of the empirical formula is 47.034 grams per mole. We are going to divide this number by this number, and you will see the ratio is 5. So we are going to multiply this empirical formula by 5. That means we have C5H15 and O10. This is your actual molecular formula. This is the end of this session, and please let me know if you have more questions. Thank you.